All right, today we are joined by Elton Stoneman from the Docker Developer Relations team. Thank you so much for being here, Elton. It's going to be an amazing conversation, I know already, just from the pre-conversation that we've had right before we started recording. You are, of course, working for Docker right now. You're also an avid blogger at your blog, where you talk about a lot of really interesting things, a conversation that I would love to have with you in the future about running Windows applications inside of a container, which will be a ton of fun if we can do that at some point in the future. You're also a very well-known speaker inside of the Docker community. You're going to be speaking at the upcoming DockerCon in Austin, Texas, which unfortunately I won't be able to attend, but it is literally right in my backyard down in Austin, Texas. Unfortunately, I won't be able to be there. But as you said earlier, those sessions will be recorded, and I am very much looking forward to watching those. In previous jobs, you've worked with big data applications inside of Azure, and you eventually moved that over to Docker, as you mentioned to me previously. You've got a lot going on here, a lot of great experience with Docker, and I'm really very interested to start with to kind of figure out how you got into Docker to begin with. What was your first real experience with it and your first real success with it?
Yeah, that's great. Thanks for having me, by the way, Derek. So I spent most of my career consulting in the Microsoft stack. So,
okay, nice.
I'm a Microsoft MVP, and I've spent a lot of time building out .NET applications,
Right.
architecting them, delivering them on Azure, that sort of thing. The project you mentioned, the big data project, actually started out as an API project. I was the team to deliver an API for a mobile device.
Okay.
That all went on Azure. So that was a .NET project, but actually it was a cross-platform team because it was an Android device.
Nice.
So we had a bunch of guys working on Linux, we had a bunch of guys using Macs and all that sort of stuff. And we started getting into Docker for our toolset. So we started using it for our Git repositories. We had a Git server already on Docker. We started using it for our build agents, all that sort of stuff.
Nice.
And it just simplified so many pain points that we had
yes.
that I started to get really interested. And although I've been like a Windows guy for most of my career, I've always had a Linux server like in the garage or in the loft or something, running a bunch of stuff at home. And when Docker started to get like stable and usable around about sort of 0.8, I Dockerized all my stuff at home.
Nice.
And that made that everything easier then. And so then I started getting really interested in it, started exploring more, became a Docker captain, which is Docker's equivalent of the MVP program.
Right.
And the project I was working on, that cross-platform project, the big data side of it was going great guns. We had a bunch of stuff running up on Azure on all their managed kind of big data platforms. It was costing a lot of money to run, which is fine because we had this big program to deliver all these Android devices. So there's going to be phase 2 and phase 3 and phase 4. So we were spending like $50K a month on Azure, but nobody cared because we were getting some really good data to drive the evolution of the product. And then the roadmap for the product got canned, so they weren't going to make it anymore. So suddenly we got this massive Azure budget that we could justify, and we didn't really need the data anymore. We weren't going to be iterating on the device. So what I did is we took the APIs that we had, which were quite rich APIs that we developed to make it easy to publish new data and stuff like that. And I took all they were RESTful APIs. I took the GET requests, put them all in a static Nginx website. So the devices still thought that the API contract was still the same. They still thought they were talking to the API, but actually they were all getting the same response back. Any data they posted up, we just threw it away. So we moved from having all this API stuff to a really simple, easy to manage static website. And all the big data stuff, we moved that to Elasticsearch and Kibana. We were using Azure Event Hubs, so we pulled the stuff out of Azure Event Hubs, put it into Elasticsearch running in Docker. We had a Docker container for Kibana and a few dashboards of the key metrics that we still wanted. And our Azure bill went from like $50K a month to $500. So
that's a big difference.
Yeah, exactly. So that was all Linux containers. That's when I started getting heavily into it. It was a really good project to be involved with. And then when towards the middle of 2016 rather, when Windows Server was talking about having support for Docker, being able to run a Windows app in a container, that's when I started to get really interested, because obviously that then folded into the sort of experience of projects I've had most of my career.
Yeah, nice. There's a lot going on with Docker these days, and I've only been using it for about a year at this point. My first real success was actually solving one of my own big pain points of trying to get Oracle to run in a development capacity. I spent like 2 weeks trying to get Oracle installed on the official Oracle Linux that they distribute, and I just couldn't get it to work at all. And a friend of mine suggested trying out Docker because somebody had built an Oracle XE image for Docker. Literally within 30 minutes of that conversation happening, I had Oracle up and running. It was a phenomenal experience, and that really drove me to find more and more and more on the development side of things, which is really where I have been heavily focused. All of the work that I have done so far to date has been probably 98 to 99% in the development side of things. And I get a lot of questions. People ask me, "Hey, Derek, what should we do, about provisioning and about logging and monitoring and all these production concerns?" And I am clueless. I have almost zero experience when it comes to Docker in production. So my first real question here, what I really want to know is, what can a guy like me working independently, just doing some small applications in Docker, what can I do with my one client where I have a machine that's got too many apps on it and they're starting to clobber each other? What's the easiest way for me to get Docker into production?
Yeah, great question. So a lot of it comes down to what are your availability requirements? What are your scale requirements?
Right.
Do you need to have failover support, all that sort of stuff?
Yeah, and let's start with none of that, because right now the application server that I have running for my client, it's running forever JS as just forever. Start this node script and it'll restart 5 times, and if it fails 5 times, the app goes down, and eventually somebody will notice that it's down, and they'll text me, and I'll go start it again. So let's start there. Let's start with the dumbest possible way, with no automation, no automatic anything, restarting, clustering, failover, nothing. Let's just go. Can I just Docker run -- restart equals always?
So yeah, you can do that. So what you need to bear in mind when you're doing that is that Docker, when it starts the container, inside the Docker image, you tell it what process to run when the container starts.
Right.
And when you start that container, Docker will monitor that process. Yeah. And if the process goes down, Docker knows the container's gone down. Mm-hmm. If you set it to restart always, it will restart.
Right.
There are limitations with that because, of course, it's just a liveness check. It just checks the process is running.
Right.
If the process is running and it's a web server, but it's maxed out and every request is getting a 503, Docker still thinks it's up because
right.
the process is still running. So that's where the health check command comes in. So any application you're going to put into production, you should have a health check in your Docker file, which is basically a little script that you put inside the Docker file to tell Docker how to check if your app is actually healthy.
Oh, really?
So as well as checking the processes up, it will run that command every 30 seconds. You can configure how often it does that. And that could be a simple thing, like on a Windows container, it would be a PowerShell command for a web app that just pings localhost. Mm-hmm. And if it gets a 200 status code, it tells Docker everything's good. If it gets anything else, it tells Docker it's bad. And then Docker knows there's something wrong with the application. The other thing to think about is if you're using in production, even if you've only got a single node, there are advantages to using swarm mode. So swarm mode is how you cluster several machines together. So it's all built into Docker. So you just run a couple of commands like Docker swarm init, and it initializes the swarm, and then on other machines you can join. Even if you've got a single node, there are benefits to doing that because in swarm mode, it uses the health check to check if the application's healthy, and it can restart them if they're not. And it's also got rolling updates built in. So if you've got a new version of your application, you can do a Docker service update and tell it to update my service to this version of the image, and it'll just do that for you. So it takes care of all that stuff, and it can do rollback. Yeah. It comes into its own when you've got more than one node, because then you can do zero downtime stuff.
Yeah, when you're doing that upgrade process, you tell it to change to a new version of an image. It would basically take one offline, do the upgrade, take the other one offline, do the upgrade, so that you have zero downtime.
Exactly that. And you can tell it, if you've got a big deployment, you can tell it how many containers to take down at a time,
nice.
How long to wait to check if they're okay, what to do if they fail, so automatically roll by, that sort of stuff. So and the other thing you can...
So is it fair to say that Docker Swarm has a built-in load balancer, that it knows how to manage all of this from... Like from my perspective as a user of a website, I would hit the URL, so to speak, of Docker Swarm, and Docker Swarm would manage the load balancing?
Yeah, absolutely. So when you publish a port in your container, so your container is listening on port 80, you publish that to the host. If you've got a swarm with say 10 nodes and your container, your web server is only running on 3 of them, Docker's got a built-in load balancer and it's intelligent. So if node 10 gets a request but it's not running the container that's listening on port 80, it will silently redirect that to node 1, which is running it, and then send the response back. So it does load balancing and it does service discovery.
Wow, that's pretty impressive. Honestly, I just had no idea that Swarm was that intelligent or that useful. That's something I probably need to look into, because I am looking at moving my applications for my client into Docker, because I've got 3 different applications running on that server. Technically, like 4 different instances of 3 different applications in various test and development environments, and I'm constantly facing a situation where I have to essentially upgrade and redeploy all of my application instances anytime I need to change my Node.js version or my RabbitMQ version or MongoDB or anything else, because they're all tied together on that one system. And it's not the largest server in the world. It's like a 4 processor, 12 gigs of memory virtual machine inside of a big virtualized environment. Not terribly difficult for us to throw more resources at it, but already a pretty good box to begin with. So I would imagine getting Docker Swarm set up on there just to run 4 applications, which would realistically be probably close to 32 containers, because one of the applications is split out into about 8 different microservices. But doing that, do you think a machine of that size, just a moderate level, business type server, would really be able to handle something like this, like throwing Docker Swarm at it? Or am I going to need a larger machine? Do I have to start talking about bigger hardware or bigger virtual machines in order to do that?
No, you don't need to have bigger machines. So Docker gives you that ability to compress a lot of work onto a single machine, because unless those containers are all maxing out at the same time, then which they presumably won't do, then you can get that sort of level of you can condense all that stuff on. The alternative option you've got, of course, is to instead of having a bigger VM, is to scale out to multiple smaller VMs.
Yeah, multiple.
So exactly. So you don't need to have a 12 gig machine. You can have 3 or 4 4 gig machines, and then you've got failover and all that sort of stuff as well. So those are definitely options. You don't need a huge amount of resource. Like my blog it runs on Ghost. I've got Ghost running in a container. I've got Nginx running in a container. They run on a 512 meg DigitalOcean droplet.
Nice.
I'm a single node swarm. I can do my updates when I need to update and all that sort of stuff. So it's pretty lean.
Very nice. So let's say we've got something like that in place. We're using Docker Swarm. We've got pretty simple scenarios set up. What are things like the classic example that comes to mind in my head when I think about scaling Docker and growing production and automation is that Kubernetes thing that I constantly hear about, but I have no idea what it really does. And all of these other Docker related technologies, where do all of these fit in the growth and scalability to the point where I can take my application from this one little server running Docker Swarm out to more of a scalable, larger enterprise type application? How do I get there from where we are?
Yeah, so Kubernetes, Docker Swarm, and Mesos are the kind of the major orchestration engines.
Okay.
So when you move to a multiple node environment on a cluster, then there are additional concerns that come in. So you don't run a container on your cluster. You say, here's my in Swarm parlance, here's my service. This is the image I want you to base it off. Here's all the configuration. I want 10 instances.
Right.
And then the orchestration engine decides which node to put them on. It works out who's got the most capacity, that sort of stuff. Okay. It monitors it monitors your service level. So if you say I want 10 instances, if a server goes down and takes 3 instances with it, it will start up another 3 somewhere else on the cluster. Right. So all those concerns about where I put things, how I monitor them, that's the orchestration piece that people talk about.
Gotcha.
So so Cube takes care of that, and it also got a UI that lets you do the management stuff. And the same with Mesos. Mesos does other stuff as well. But those are additional things that you have to set up on top of Docker.
Right.
So Swarm is built into Docker. You unleash it with just a few commands. Cube and Mesos are a slightly more extensive way to install an additional layer on top of that stuff.
Right. Is there any real advantage to using Kubernetes over Docker Swarm, or is in my scenario, should I really just be looking at Docker Swarm?
Well, so I work for Docker, so I'm bound to say,
right. Yes, of course. Fair point.
I mean, they are slightly different things. So Kubernetes has the whole UI stuff. So you get a UI to manage what you're doing, but the language of describing your service implementation, you've got a distributed solution with several images that have to work in a certain way. The description for that is a Kubernetes thing, whereas with Docker Swarm you use Docker Compose. So if you're familiar with Docker Compose, you just take that file and you run it for all of your environments.
Yeah, that was actually going to be one of my questions. I was going to ask you about Docker Compose because I've got a few of my applications set up with Docker Compose, and I've tried to look for simple hosting solutions for those applications, my own personal stuff, not for my client work. And I've been clueless on how to do that. Like I've been able to deploy a single image to Heroku and a single image to a DigitalOcean setup and a single image here and there and a few other places, but Docker Compose is what I wanted to use because it coordinates all of my containers for me. So Docker Swarm is going to be able to do that for me?
Yeah, so the latest version of Docker, which is 1703 at the time of recording, it has an understanding of the Docker Compose file format built into the Docker engine. Nice. So when you're running in Swarm mode, you can say Docker stack deploy, that's the new terminology, the stack. Give it a Compose file, and it will take that Compose file, it'll work out what images you have, what dependencies you have, and then it will put them into the orchestration engine that will fire them up across the Swarm in a virtual network so they can all talk to each other. So you don't need to expose your MongoDB port to the world. You can keep it closed so only containers can access it, so that's where that stuff comes in. So you can work locally on a single standalone engine and use Docker Compose, and when you're ready to go to your test environment or your production, use the same Compose file, but you do it deploy it as a stack.
Right, very nice. All right, so we've gone from me running my containers in development to the crude way of just Docker run restart always, which is probably not recommended. If I'm going to do that, I might as well be using Docker Swarm, it sounds like. I should be using that because it doesn't sound terribly difficult to set up a single node inside of Docker Swarm. So we've gone from there to using Docker Compose to stand up a larger system with multiple containers that are coordinated through the virtual network inside of Docker Compose and everything else that we can do in there, which is something that I'm extremely excited about at this point. How do we go from there to running something larger, something more, enterprisey, more cloud scale, I guess, to where we have these really, truly large systems that people are dealing with?
Yeah, so that is the exact question that people had from the people who are using Docker in enterprises a couple of years back. So traditionally, devs got really excited about Docker. It removed a lot of their pain points and made it really easy to promote to different environments. And then they would take it to the ops guys who would say, well, what about this and this and this and this and this? And there was a barrier to get the new way of doing things into a production environment. But as more and more people started using Docker and the security best practices got worked through, and people began to realize actually a Dockerized environment can be a more secure environment rather than a less secure one. And then at the same sort of time, we developed our commercial offering, which is Docker Data Center. So there was always a commercially supported Docker engines. You could pay for support like you can with Linux distros. But then Docker Data Center came on as a kind of unified management and orchestration platform. So Docker Data on your own data center or in a virtual private cloud.
You broke up there again. Restart that sentence. So Docker Data Center.
So Docker Data Center is what you run if you're running in your own data center or you're running in a virtual private cloud. It gives you the trusted registry, which is like your own Docker hub.
Right.
It gives you the universal control plane, which is a single pane of glass to manage all your nodes in your cluster,
Very
all your
nice.
applications, all your images. And actually, soon you'll be able to run a hybrid swarm. So you'll be able to have some Windows nodes, some Linux nodes, and have hundreds of containers running. Some might be Linux apps, some are Windows apps. You manage them all in exactly the same way through the same UI.
Right.
And the latest thing that's come into Docker Data Center or Docker Enterprise Edition is security scanning.
Okay.
So as part of your I don't know if you've seen on Docker Hub, some of the images, you can look at them and you can see that they've been scanned for security problems.
Yeah, I've seen that.
Absolutely. Yeah, so the official images. So you can do that with your own images now.
Very nice.
with Docker Data Center, you can have it periodically scanning images, or you can have them every time you push them. It goes to a known common vulnerabilities and exploits database, and it will tell you if there's a problem with the operating system or with any of the dependencies that you use in your app or the version of your application framework. It'll flag all that stuff up for you. So yeah, it's a kind of end-to-end package.
Very nice. Now I can imagine being Docker and being an image, a distributable version of your entire application as a single binary image or layer of images, that the security scan is probably going to be pretty intelligent in that it would scan the image directly or stand up a new container instance in order to do all of that. It wouldn't be invasive into the actual running containers.
Oh yeah, so it doesn't touch your containers at all. It works on the image level.
Okay.
It doesn't spin up a container.
Really?
Because the image format is well understood.
Right.
The scanning tool can look at it, does it a layer at a time. It can look at the layers, it finds out all the binaries that are installed there, and then it compares it, gets all the versions, compares it to a known database, and yeah, that's how it does it.
Honestly, that's one of those things that still kind of blows my mind about Docker. Because in the past, when I've talked with security people about all these kinds of checks and monitoring services and everything, it's always one more service that we have to install in the actual production server, in the firewall, the DMZ, and in the whatever it is, which takes up more resources and means we need a bigger box to begin with, and we have to contend with all the security lockdown. I mean, it's the equivalent of I guess SE Linux. Being the security kind of just pull my hair out, nightmarish, frustrates me all the time kind of thing. But now we're talking about the ability to I mean, you got to have your image secure. You got to have, you may have SE Linux running inside of your image in order to keep things secure. But now we're talking about the ability to scan the image that this is built from, the equivalent of taking your installation CD for Windows, putting it into a drive and scan all the files on that drive to tell us whether or not the image itself is secure instead of having to run it live inside the real box. And that's
absolutely, yes.
That's
so if there is a problem, it's all offline. Yeah, that's right. And the other thing you get with Docker Data Center, while you're talking about security and provenance, is you can digitally sign an image before you push it to the registry inside Docker Data Center.
Very nice.
And you can configure the cluster, so it will only run images that have been signed by, you can either say a certain number of teams. So you might say an image has to have been signed by the QA team and the security team and the release team before it can go and run in my production cluster. Wow. And if somebody tries to run something, it just won't even start. So you've got the provenance of saying, here's my image, this is the exact version, these are the people who signed it, this was the security scanning result. We know exactly what's in there, and your audit trail is there's no way to break into that audit trail is secure.
Yeah, so you're really talking about change management and SCM at that point, where you're dealing with truly large enterprises, people that have mission critical applications, and they have a necessary level of bureaucracy in place in order to make sure that things are, to the best of everybody's knowledge and ability, things are going to be stable when it gets deployed.
Yeah, exactly. Yeah, and then this kind of takes out that to the best of your knowledge, because it's all documented in the system. It's all stored. Very
nice. That's pretty amazing stuff. That brings up the question of how do you deal with continuous deployment in a scenario like that? Is that something that Docker Data Center would support and help us with, or is that going to be like a different set of tools in combination with Docker Data Center?
Yeah, so the build process is, there isn't a build process built into Docker Data Center like you get with, at the moment on Docker Cloud and Docker Hub, you can have an automated build. So it will monitor a Git repo and it will find your Docker file and it'll build it for you and push the image. That's
Yeah.
not a feature in Docker Data Center as of yet. But the way you build, when you move to a Dockerized solution, the way you build your components is ideally with a Docker image that is a build agent.
Right.
So you don't have to have Jenkins installed on a machine. If you've got
Yes.
a .NET solution, you don't need a build agent that's got Visual Studio installed, anything like that, because all the requirements are in a separate Docker image, your builder image.
Right.
And so your build process is just a couple of lines of script that say update the builder image to make sure it's got the latest stuff, and then run the builder image, which takes your source code, builds it and produces the output, and then build that Docker image from the output from the builder, and you've packaged your whole solution up. So whether you want to run Jenkins or whatever you're going to use to coordinate that, GitLab or whatever, your actual build process is 3 or 4 lines of script. You can host that however you want. So there's nothing built into DDC as yet, but of course you can DDC lets you take your cluster of X number of machines and label them for use in different ways. So you could say, well, I've got 5 or 6 machines here that are my build machines. I'll put a label on them, and then when I do something like run Jenkins, I can constrain it to only run on certain known machines. So you can segment a larger cluster and give it to the QA team or give it to different projects. And then you can run your CI however you choose.
Right. So with all of these machines that are being stood up, with everything from Jenkins to production applications to whatever it is Docker Data Center going to give us the real big picture in terms of management and monitoring for all of that, or are we going to need to add on additional kind of dashboard things in order to see what's going on inside the data center? Like when it comes to cloud stuff, my real cloud experience is Heroku. I mean, that's what I know of as the automatic scaling. Drag a slider to add a new dyno, and there we go. That's my idea of the cloud. But what's the reality of monitoring and management from an operations perspective? How does Docker Data Center, give us those features and facilities?
Yeah, good question. So Docker Data Center's got Docker Data Center is a web UI called the Universal Control Plane, and that's how you look at the apps that are running on your cluster, monitor them, and do your scaling up and scaling down. So that your exact example there, you do that in UCP. So you log on. Here's my message handler service. I've got a big spike in load, so I need some more. You literally change your service level from 2 to 10 or whatever, and it puts them on the nodes of your capacity and takes care of all that stuff.
Nice.
If the node doesn't have the image, it will download it, all that. It takes care of all that for you. In terms of monitoring, because when you run your application in Docker, it exposes a consistent API no matter what's in there, whether it's a Go app or Java or whatever. You can do Docker top and see what's running, what process is running, Docker logs to pull the logs out. UCP scoops that stuff up. So you can there are 2 levels of monitoring. At the node level, you can see how hard each node is working, CPU, disk, network, all that sort of stuff. It gives you those fancy graphs to say, here's my 10 nodes, they're all healthy, or one of them is unhealthy and we're looking into that or whatever. Here's how hard they're all working. And then you can drill down into the individual containers that are running on the machines. You can see the CPU and the disk load of each container. And you can even exec into the container. So it gives you, the web UI gives you a console, so you can go into the container if you really need to, and see what's going on. So yeah, it scoops that stuff up. But of course, with Docker has this plug-in model for logging, so you can direct logs to something central. If you've already got a logging or an administration tool in place, there's probably a plugin that you can scoop up to all the logs into what you're currently using.
Nice. So we've kind of gone from the core of development and how I got started out to the basics of production, through growth into the enterprise. Let's bring it back around at the very end here. Me as an individual developer, I have a pretty big client that I work with. I have my own applications that I build for Watch Me Code and for other things that I toy around with. At what point do I, as a developer, as a small-time shop, essentially, at what point do I know that I need to move from Docker Swarm to something more like Docker Data Center, to this large enterprise scalability managed for me but running in-house? How do I know when I need to move to that point?
I think that's a good question. So I think it's going to come partly down to the level of service that you need to provide. So
Okay.
SLAs that you've got for your clients,
Right.
and partly it's going to come down to the level of support that you need as the owner of those applications.
Okay.
So Docker Data Center is really aimed at enterprises who want 24/7 support for something that goes wrong with Docker or with one of the containers or something like that. So Docker Data Center is at that far end of the extreme where we're talking to significant, FTSE 100 businesses. And we're getting, they're moving their existing workloads onto Docker, but they don't want to use the community edition because they want someone who they can call if something goes wrong because these are business critical apps.
Right.
In between, from the community edition of Swarm through to Docker Data Center, there's Docker Cloud. So Docker Cloud is a kind of that's more aimed at your a single project team that are running on Docker, or a smaller shop that's going to do some stuff for you.
Right. That's probably the equivalent of when I would use Heroku instead of Heroku, which is abysmal for Docker support still. Then I would push to Docker Cloud, right? And that's like hosted for me in the cloud. You guys manage that and take care of everything for me.
Yes and no. So it's in the cloud, but you bring your own cloud. So we don't have our own data center full of machines, because who would build a data center nowadays? So if you're an AWS user or an Azure user or DigitalOcean, you can give Docker Cloud your credentials, and then you say to Docker Cloud, spin me up a swarm of 10 machines, and it will create them using a best practice template for Azure or AWS. It will use all the right. If you're an Azure guy, you'll be familiar with the idea of network security groups and all that sort of stuff to lock it down. So you've got a nice secure deployment, and it's scalable. So you can add more nodes because Docker Cloud can do that for you. And then the way you interact with that is it's just Docker Swarm. It's remote, but you can get remote access to the Swarm. And on Docker Cloud, you've also got the automated build stuff.
Yeah, so that's making a whole lot more sense from my perspective right now, considering how I tend to deploy applications to DigitalOcean or Heroku right now. I can stand up 3 or 4 boxes on DigitalOcean and get a nice little array of really small boxes to run my application for me, and put Docker Cloud on top of that, have Docker Cloud managing the container instances on those servers for me, and be able to log in. I assume at that point I would log in through Docker Cloud to manage all of that.
Yeah. So Docker Cloud is a separate web UI. You log into that, you can see everything that's running. And literally, that came out last week, I think, is the ability that we call it fleet management. So if you're using Docker for Mac or Docker for Windows, you've got the little Moby whale icon.
Right.
If you've got a Docker Cloud subscription set up with one or more swarms, you right click and say, now switch to this swarm, and you manage it all through your local laptop. So it's all super simple.
That's pretty cool. All right. Well, I really appreciate your time today, Elton. This has been, for myself personally, this has been phenomenally insightful. I honestly, I had zero clue how to get Docker Compose into a production environment. I looked and looked and looked, and apparently I just didn't ask the right questions previously. But Docker Swarm sounds like the thing that I need to be looking at for my client work and for a few of my own applications. I'm definitely going to check out Docker Cloud for a few of the small apps that I need to deploy, which I'm currently deploying to Heroku, but kind of getting tired of the way Heroku works right now. A lot of things for me to look into, a lot of stuff for me to dig into, and I know the viewers of this video are probably going to be in the same boat as me. Really appreciate your time today. Thank you so much for being here.
You're welcome. Thank you very much. Take care.